Okay, my friends, this is going to be quite simple to understand. We're dealing with the atmosphere. And if you have global warming, it means that just not the Earth is warming, it means the atmosphere is warming and is becoming turbulent, which is causing all these weather patterns and so forth. We're going to get into some details about this, and it's going to get a little complicated, but you should fully understand it with no physics background whatsoever, or you don't have to understand anything about space. We're going to be looking at how the planets go through the solar system and spin and rub and scrub. I believe this is the issue that we're dealing with, and it's not being fully understood. Let's talk about it. All right, let's just deal with what we know and we can show and prove and is well understood. These are the things that are well understood. We can look out and see the spinning galaxies in space, and they do spin, and we are on one of these arms of the Milky Way and spinning this way. Our whole solar system is moving through space like that, which gives it this inclination, which is this, where the sun is being pulled forward through the solar system, and we have to follow it because it is our gravity. It pulls us towards it, and it is moving forward, so we are moving forward with it. But in addition, everything spins as it moves forward. If you're moving forward, there's a spinning effect that takes effect. And everything spins, and it all spins in the right-hand rule. Now, we're going forward, all right, through space on the arm of the Milky Way. We're spinning as well. And then we're circling the sun. Now, here's the sun, and here's us. All right, we are spinning this way. The sun is spinning as well. And where the atmosphere of the sun hits the solar system, what's supposed to be a vacuum, which is not, it creates extreme amounts of energy. It's millions of degrees in a corona, millions. Here's the picture, hold on. I drew this little picture just to show you simply. The solar system and space in general is 100% saturated with particles, and the Fermilab says it's called the quantum foam. It's out there, and there's nothing, and it's empty space is not empty. I'll show you the article. Now, here is the scrub zone of the sun. Here's the surface, 10,000 degrees. Out here, there's still got, it's just atmosphere out there, but it's going with the sun as it goes forward and spins and all that stuff. It's millions of degrees out here, millions, from 10,000 up to millions. Nobody has an explanation for that, none, zero. Same thing on Earth. Earth is 100 degrees or so, let's say, on the surface. And when you get out to the far reaches out here where it's called the ionosphere, it goes up to almost 3,000 degrees. Nobody has an explanation. Nobody can explain that. 3,000 degrees, why? Why from 100 up here to 3,000? And in between, it goes to minus 80. How did that happen? And that's Celsius. So it's way low in temperature, and it's way high in temperature, and then it comes back to sort of 100 degrees. The sun is radiating out all these particles. And I can show that as well because we can see it in a solar eclipse. And here that is. All right, see, this is a solar eclipse. The moon is over the top of the solar disk, so it's obscuring us from being blinded by the light. What it's doing is letting us see where the light is going. This is quite obvious, the pole of the sun, which means it's spinning like this, because it's got a north and a south pole. Just think of this as the sun, it's just not radiating. So this is the sun. It's actually the moon, but let's call it the sun for today. That's the North Pole, that's the South Pole. It's spinning this way. You see that red, red, red? Can you see that? Those three little red spots are the impact zones of the planet spinning and pushing forward. and they create a big magnetic field around themselves to push the other zones away from each other. See, so you go zone here, a zone here, and a zone here. On the other side, as it comes around here and then just trails off, this is just sort of, you see it, look at how it comes here. See this? You see this? That's just fluffing off and just stripping off. This is pushing out with violent pushing. You see it? This is just sort of trailing off. It's being rubbed off. There's no glowing over here like this. So we know it's spinning this direction, creating the poles, and we know it's moving in that direction, creating this extreme heat on the facing side that's turning into those particles. This is the trailing side, just sort of rubbing away from them. So there's nowhere near as much interaction here. So out here it's probably, instead of 1 million, it could probably be 2 million. Over here it maybe be 1 million, whatever. But it's throwing off all of these particles everywhere. And those particles have to come to the Earth. And that is called the quantum foam. Now, this is Fermilab. We found these particles using light. They found them using protons, but they just have a big mix of stuff. They don't know where they really came from. They are literally what creates light. Now, everything he says about them is true. This has nothing but solid mass and a glowy surrounding it, and this is fluffy and small and has no mass at all basically, but it's all the burn. That's all the weight and that's all the burn. Now he also says down here that there's a quantum foam in the universe, and the quantum foam says that empty space isn't empty, it's completely saturated with particles. And how do they react? Here's how they react. It says the foam on the head of a root beer is a complicated environment, bubbles appearing and disappearing in a dizzying display of change. Flick, 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 flick. Empty space experiences similar activity with subatomic particles winking in and out of existence. These ephemeral subatomic particles are real and have a measurable impact on the universe. They slow light down. They create heat. When they get banged for a second, they glow and they stop as another particle of light hits them. So here's what's going on in space. Well, let's get back to the sun. All right. So here we are out in space, which is not empty. It's completely filled with what they call the cosmic microwave background. It's just little particles that are just floating around. They were particles of light, and they've become so slow that they're just drifting around. So as these light particles, which are very energetic, smack into them, they turn them on and off like little fireflies. And that's exactly what John Glenn said when he went into space in 1962. He said, "I'm surrounded by fireflies. They're everywhere. There are all these little glowing like little stars all around him," and that's because these lit him up. And he was probably seeing a lot of dust particles which would stay lit up. The light particles get hit on and off, and they flick on and off and turn on and off, but they're just particles of light. All right, the dust that surrounds the atmosphere, which we have tons of dust out there, tons and tons and tons, and when they get hit by the light, they turn on and they stay turned on. And that's exactly what John Glenn said. I think I might even have a tape of him. Hold on. You know, I can't find that one with John Glenn. It used to be up there. It's not there anymore. But here's what happened. When he first went up into space, they shot him up into here. Now, as he was coming around the edge here, so think of this now. The light's coming down here like this. There's no light here. He's in the dark. But he's looking off through the lighted up sky that's in front of him, which he said, wow, there's a million of these little fireflies. They're going about the same speed as he was, a few more miles per hour maybe, but they were rotating with him basically around the Earth, and they were all lighting up as he's coming this way, and then they went away because he's now in the midst of them. Just like if we're looking at the sun, you can't see the sun. If you took this off, you just see nothing but brightness. So that's all he was seeing out here. Now, when he came back this way and he got into the darkness again and looked back, he could see him again. So it was the light hitting all these little particles that are all in the edges, just like you walk in a barn and you see light streaming through a little crack and all the dust lights up and you can see it. That's what he was seeing, all the dust lighting up here. So that's what John Glenn saw, and he called them the fireflies. And they are what we're scrubbing through. And right now, they are becoming increasingly dense. All right, let's set some ground rules up. We know we're spinning on an arm of the Milky Way. We know that the sun, and we're spinning around the sun and moving forward on one of these arms. So we're spinning, we're being torn forward, and we're spinning around the sun as well. So there's a lot of interaction on our planet. Now, looking off into space, this is just nothing more than a picture taken with a cell phone. I'm not kidding you. I don't know how he did it, what app he had in here, but these are nothing more than magnetic fields. That's the moon, and these are all magnetic fields given off by these dipole planets. Everything is a dipole when it spins through space. It sets up a dipole, a magnetic polarities, a positive and a negative zone. Just like I show you the sun had that, the north and south pole. And it's just like this right here. Whatever that planet is, there's something behind the moon. The moon doesn't give off a magnetic field. It's not spinning. The other part, or the other things in space do primarily spin. The moon is just sort of locked there and it rolls around with us. But it does impact and create a blue zone up here versus a more red zone here, because it's going this way, crushing the fields of the particles of light. That's why it shifted to the blue. Now, that's pretty impressive. Now, all the particles coming through space have to go through these. Those are all resistance. Every time you go through one of these things, that slows you down until you stop. And that's what's happening to all the particles in space. They're not being shifted red because they're being pulled away. They're being shifted red because they're going slower and slower and slower and slower and slower. And finally they stop. And it's called the cosmic microwave background at that point, because they're just particles floating around here. They become the quantum foam, just like Fermilab said. Okay, so let's take a look at the temperatures. This is the Earth. This is the atmosphere, basically, that rotates with the Earth. Now, this is the outermost layer, has very low density. That's the exosphere, where you're outside. This part here basically is scrubbing. Out here, it's just barely moving along, so it's very low density, way, way, way out. Now, right here, though, different story. We're scrubbing this zone right here, which is called the ionosphere. See the ionosphere? Ions mean electrons. They mean heat. Ions are electricity. And what happens is they scrub, and they're being stripped from the light particles that are hitting us. That's it. And they're scrubbing, it's scrubbing all day long as these things impact into it. Now, at night, it's a whole different story. There's very little scrub going on of incoming particles. There's still scrub because out there is just another zone that we're scrubbing against. But during the day, it's solar maximum is coming into us, pushing on top of that. So we're scrubbing and then pushing. Now, why is it getting worse and worse? It's been like this forever. Why would it get worse all of a sudden? What's that got to do with fossil fuels? It's got a lot to do with fossil fuels. Long ago, when they first drilled oil, everywhere they drilled the oil, they would call it a gusher. All right, so they'd go into the earth and there'd be nothing but oil spilling everywhere. It's gush, and then it was just unbelievable how much oil would come out of these wells. Well, that's a thing of the past. We've depressurized the earth. The earth is literally collapsing, and there's sinkholes everywhere because there's no more pressure inside the earth. When they pump oil out of the earth now, they pump like hell to get it out. Before, they just tap it and just run it out of a tap like it was nothing. There's no pumping at all. It was just a gusher coming out of there because there was so much pressure inside the earth. That's gone. Now, everywhere there are sinkholes. I studied sinkholes extremely well, and they are getting very bad, and they're getting worse and worse. And that's number one. So this is collapsing the Earth's fabrical surface. Well, what happened to that oil? What happened to that oil? Okay, I am going to assume that you are intelligent enough to understand that when you heat something up, if it's in a gas, it expands. And then it floats up in air like a hot air balloon. When you first have no air in it, it's just not expanded. You put more and more heat in it, it gets bigger and bigger. You want to go higher, you put more heat in it. It just keeps getting lighter and lighter because there's more and more heat in there, which means everything is expanded out. So what happens when you burn things? Well, we all know about carbon dioxide. CO2, it's a disaster. It keeps the heat from being able to escape. That's what they think. They think the heat will escape. The heat does not escape. Heat is forced into the earth, towards the earth, in the ionosphere, because of the sun hitting it. It is 1,500 degrees Celsius out there. That's, I think, 2,700 degrees, 2,700 degrees out there. Why? Why would it be so hot out there? Because just below it, it's minus 80 Celsius. That's cold as hell. This is hotter than hell, that's cold as hell. That is exactly what happens when you have the interaction of a dipole. There's a hot side and a cold side, basically, is the way it works. One of them is a charged end, and one of them is a discharged end. One of them has all the energy, but they have to be scrubbing. If they're just sitting, it's a whole different story. But when they're interacting and scrubbing, this becomes extremely hot and this becomes extremely cold. The hotter this gets, the colder this gets. And they're saying right now, this is getting colder and colder. So they take it as it means that it has nothing to do with outside influence. No, this gets hotter, this gets colder. That is the nature of dipole interaction when you're scrubbing. When you increase the heat here, you increase the cold there. And that's exactly what's happening right now. All right, you got to get into a little bit of physics to understand this. But the hotter this gets, the more densely packed the electrons are. But they have no weight, they have no mass. All the mass is in the cold part. So the colder this gets, the more massive it's going to get. All right? So if it was minus 80, if it goes to minus 85, it gets more dense. Which means as it spins, it scrubs harder and harder against the layers below. So we get more turbulence and we get more condensation. All right? And if it gets colder and colder, we get more big chunks of ice, which is the hail, huge hailstones coming down now because of this extreme amount of cold and condensation. All of this is really packed onto the earth because every time you take a drop of oil out of here and you burn it, that drop, when it was a drop, tiny drop, it becomes this big. You burn 2 drops, it's that big. 3 is just gigantic. We are just blowing this up just like you'd blow up a hot air balloon. No difference whatsoever. None, zero, identical. Our atmosphere is going way, way, way up and crushing harder and harder and harder, making this get colder and colder, hotter and hotter. And Yale University, who I have had my issues with, doesn't understand this at all, once again. Let me see tell you what Yale has to say about it. I have it completely, totally backwards. Don't forget, the hotter this gets, the colder this gets. All right, the hotter it gets out here, as long as it's in the envelope of our Earth, it's going to heat up and cause more and more turbulence down here, condensation, weather pattern disruptions, and the heat migrates its way down. One way or the other, we're going to get global warming down here. All right, all of this is a layered effect, but the cold right here indicates to me that there's more and more interaction out here, and it's because the expansion brings us into more and more scrub. The bigger the envelope of the gases, the more and more the scrub. Simple as that. Now let's see what Yale has to say. All right, this is Yale University from, this just came out a few months ago. And this is the School of Environment. And here's what they're saying. The upper atmosphere is cooling, prompting new climate concerns. A newest study reaffirming that global climate change is human-made also found that upper atmosphere is cooling dramatically. And they say because of a rising CO2 levels. Now, here's the problem that this was just from 2023. there's a paradox at the heart of our changing climate. While the blanket of air close to the Earth's surface is warming, most of the atmosphere above is becoming dramatically cooler. The same gases that are warming the bottom few miles of air are cooling the much greater expanse above that stretch to the edge of space. Well, that's up before you hit the ionosphere, because the ionosphere is hotter than hell. Then you get into that very cold layer, and then you get into another warm layer. It's hot, cold, hot, cold, hot, cold. That's exactly the way it works. It's the difference, a change. Every time you get a pressurization here and it creates a heat, you get a cold opposite. That's the dipole nature of everything. Okay, this is from the Yale paper, and it says the story of changing temperatures in the atmosphere at all levels is largely the story of CO2. They say everything is happening because of CO2. We know all too well that our emissions of more than 40 billion tons of the gas, in other words, CO2 gas, 40 billion tons of that gas, which is just particles of gas, 40 billion tons of them, annually are warming the troposphere. They're expanding the envelope of the Earth just like they would a balloon. This happens because the gas absorbs and re-emits solar radiation. It might do that, but that's not the reason that we're getting overheated. They say that is what's heating other molecules in the dense air and raising temperatures overall. Well, there might be a little of that. Sure, there's going to be more particles in the air to absorb more other things, but that whatever comes into us is being absorbed anyway. It doesn't matter if it's being absorbed by CO2 or whatever. We are expanding our envelope. That's what's making it force these particles into us. We're scrubbing a bigger and bigger ball through the same amount of soup, and it's just getting hotter and hotter. Okay, so this is Yale, and this is published from the Yale School of Environment. And here's what they have to say down here. It says that increases in the CO2 are now manifest throughout the entire perceptible atmosphere, a physicist says. Until recently, scientists called the remote zones of the upper atmosphere, which is the ionosphere, the ignorosphere. They never bothered to even look at it. They knew so little about them. They had no idea what's going on up there. So now that they know more, what are we learning, and should it reassure or alarm us? Well, we've got to understand it first, and that is the scrub zone. That's where all the particles in the ionosphere, that's why it's 2,700 degrees out there. The only thing that creates heat is excess electrons, which are ions. All right, the ignore zone, I've been going on about it. I'm saying this is the source of our global warming, is the ionosphere. Well, they're coming around to realize this. You see, the climate change almost always thought about in terms of the lowest regions of the atmosphere. But physicists now warn that we need to rethink this assumption. Yeah, you really do, because it's the outer scrub zone is where all the heat is being and all those ions have to come down into this zone, and they will warm us up. And they're saying it's because the CO2 is now getting so high up in the air. No, it's because the air is just expanding and we're being blown up like a big balloon. Okay, at least we got one thing right here from Yale. It says if we don't get our models right about what is happening up there, we could get things wrong down below. And that's exactly what's happening now. Okay, and here's the conclusion from Yale's paper. It says that Mizik is hoping to reboot interest in monitoring with a special session that he is organizing at the American Geophysical Union this fall to discuss the upper atmosphere as the next frontier in climate change. Without continued monitoring of this area up here, the fear is we could soon be returning to the days of the ignorosphere, which is outer space ignore this ionosphere. Well, guess what? They ignore the ionosphere as well. Because right now, every time you take oil out of the ground, or any natural gases, or anything that are expansion gases or oils that are filling up the Earth is collapsing. It's literally collapsing. They used to drill oil well, and you would get a gusher. They couldn't even stop it. They would have to put caps on there, and then they just turn it on and run as much oil out of there as you wanted. And it was happening everywhere around the world until they took so much pressure out of the earth and so many fluids out that the earth is literally collapsing. That's why all these sinkholes are showing up, and because it's warming up, the areas that were pretty solid because they were basically frozen are no longer frozen, and they're sinking. And that's what happened. It's happening all over the world, but Russia has a lot of problems where they're pumping a lot of oil, especially in that Yamani Peninsula up there. And I talked to the Russians about that problem back in 2015 or 2014, I think it was. And they were just starting to have these huge sinkholes showing up. And I knew what it was because I had been posting about it. These sinkholes are a product of sucking all the gases and oils out of the earth. And as the tundra and so forth warmed up, they're just collapsing. They're all over the earth. They're happening everywhere. It doesn't matter whether it's hot or cold because there's no more pressure in the earth. Now they have to pump the oil out, a lot of energy to pump the oil. Before they just turn it on and come out. There's no more pressure in the earth. All of that, every time you take a drop of that out, it turns into a ball this big of gases. When you burn it, it comes out as, first of all, it comes out as a little ball and a little, just a drop. When you burn it, it's just like this big. So you burn enough drops, you got billions of tons of gases. Think of this, 20 billion tons of gases, whatever it was. And we're just blowing our envelope up like this. So it is carbon dioxide, basically. I can agree with that, but it's not because the carbon dioxide is absorbing a light. It's because the carbon dioxide is what happens when you burn something, it expands. All right, so you saw the Fermilab, and I have found these particles, and that one is the muon, and that one's the electron neutrino, and that literally is dark matter. It doesn't absorb, it doesn't emit, it doesn't reflect, it doesn't do anything other than attract. And this is also gravity. These are the two things they've been missing. They can't find dark matter, they can't find gravity. There it is right there. All right, we are scrubbing through the solar wind. As I showed you before, we are behind the sun. We have to go through the sun's particles in addition to whatever else is out there in space. But we have to come behind the sun. So we are in the path of the solar wind. And what is the solar wind? All right, this is what's in the solar wind. They're charged particles. That means they have extra electrons. And it's in the atmosphere of the sun called the corona, and that's where all these charged particles are primarily get liberated from the sun. It's a plasma, and I showed you the white particles are the plasma that I've been showing over and over, or I will show you some more. And that plasma consists, all right, sorry, a little interruption there. The plasma that's coming at the corona of the sun, it consists of electrons, protons, alpha particles, kinetic energy, real high energy stuff, and also all of these little trace metals and minerals that are same stuff that's on Earth. It's coming out from the sun. Now, primarily it's the plasma, and the plasma is what we created when we shot the stuff through the Venturi. All right, this is plasma right there. That's plasma. All right, and that's what you run your car on. I don't care what anybody says. If you can separate the white from the black, that's how you generate electricity. When you run it through a generator, you have to literally manually rip them apart. That takes energy. That's why a generator has and it's ripping the particles apart and ripping the white away and putting the white into a battery where you can let it flow through wires to do whatever you want. But it just goes by itself. It wants so badly to be back to that black that it will go through the wire to find the black. And that's what it does right here. It recombines right here. That's when they make the Higgs fields. Higgs fields are backwards too. They think the Higgs fields decay into these particles. No, these decayed particles recombine to form the Higgs. They have it totally backwards. These are the Higgs. And when they're combined, they're Higgs fields. When they're not combined, they're particles like that. All right, I'm going to sum this up right now. These are the particles they found at CERN and Fermilab, the smallest particles that exist. And this one burns everything, and that one knocks things down. The black ones and the white ones. The white ones can get big and small, but the black ones just bang things down. Now, we were able to accelerate these photons. That's a photon of light. And we were able to accelerate them by putting it through a venturi. That's the acceleration, and then exploded at the venturi. And the black separated from the white, which it looks like fission to me. And that's fusion, where it comes back together. Now, in the meantime, it's raw white energy, which is the energy you use to run your house and your car and everything else. It's electricity. It has no weight whatsoever. And I'm going to show you this in an atomic bomb blast. This is literally the atomic bomb blast. And out here, we're going to see the white come out first and burn something down, then the black. And here it is in a better shot. There's the atomic bomb blast right there. All right, so it explodes. Well, what happens when it explodes? What is a bomb, first of all, made of? Well, there's a bunch of dark matter in the center of it, and it's coated by the white particles, which are the glowy ones. But inside is a dark core, black inside. When it goes off, all the white ones go off first, you see them? And the black is pushing them, basically, as that's what's happened. The white have no mass whatsoever. They just go all by themselves, and all they do is burn things or heat things up. The black pushes things, and it is matter. Black is the matter that we stand on. Of course, it's mostly attached to white ones, but there's more black ones in the Earth. That's what creates gravity, because black sucks the white ones. And that I can show too. They did this in outer space, the Russians. The black sucks the white particles in. These are charged particles in a vacuum chamber in space. And that's what happens. The more white ones cross, the closer here, just like around the Earth. That's our atmosphere around here. And our atmosphere is glowy and burny and scrubby. That's why when something goes through the atmosphere very fast, it heats up, because it's got to scrub through these particles. Just as we show in the light experiment. Here it is right here. That's the packets of light. The photons coming through here. And they tell everybody else, get out of the way, I'm coming through. And they're little tiny particles that are just about this size, but they have magnetic fields that surround them that are big. So that's why you have a wave, because the ball got to go through there, and the particles inside of it, so you got a wave and a particle. All right, so that covers that, and we accelerated that through the venturi right there. There's no question about that. That's an acceleration. And here, there's no question that the black separated from the white, because they started out just like this. They will always be attached together. The only way you can break them apart is to do what we did with the venturi, or what Fermilab does in CERN and all that, hitting head on and smashing the hell out of them. Otherwise, they're pretty well glued together. Those things do not come apart easily. But through the venturi, the white can squish down and make it like little tiny squirty stuff. And the black cannot. The black is a fixed particle. It's precisely what they say at Fermilab. And all of them, CERN, they all say the same thing. That particle cannot change. It's fixed. And this particle can get big and small, just like I'm showing you. Okay, this is the layers of the atmosphere. Anytime you have an extreme amount of ions, which are the negative particles, the white particles, they are going to have an extreme amount of dark particles, and they have a separation zone here, because they're being forced in and creating this layer, which is extremely hot. All right, 1500 degrees. Below that is minus 80. Now let me show you what happens in atomic bomb blast. Exactly the same thing, only instead of scrubbing here, we're pushing and causing the same effect as the scrub, but it's a push from the black particles against the white particles. Just like I show you through the venturi, it's this exact same push. The black particles are pushing the white particles. This particular Venturi was tuned to a point where some of the black could get through with the white, but it still was an extremely energetic reaction. So we can see the black behind the white. In the other ones, the white was complete. You see here? There is no black coming through here whatsoever. But it does reattach here. Now let me show you the atomic bomb blast, and it's going to mimic this exact same thing. The first thing we're going to see, or hear actually, is the Whistler waves, because they're a different frequency. You see how tight these are? That's from the atomic bomb blast. Well, actually, it's the same thing. It's a subatomic bomb blast over here, a nuclear explosion. Separation of the two, the white and the black. And that's a fission and fusion. And over here, it's a ripple wave of energy prior to the particles coming. The black is actually the particle. The white is just a fluffy thing that burns. And here's what's going to happen in the atomic bomb blast. Watch this. Okay, this is from what I did a few months ago, showing this Whistler wave, and this is from atomiccentral.com. There's two things going to happen here. One is, the first thing you're going to see is the bomb go off, and you're going to hear, and then about, I don't know, 20 seconds later or something, the actual black part comes. The first part is the white part. Now listen. Before we hear the concussion, listen to this. Did you hear that? You didn't see any nuclear blast yet. You can see it. But now it's coming at us. You see this? This is the dark particles coming at us. That wave coming across. All right, you see this? Here it comes. And that is, here it's coming, it's coming, it's coming. Now I'm going to turn it back on so we can hear it hit. Because this is the black part. That has the concussion that pushes things. The white part is just, boom, there it is. That's the blast. All right, so now you heard the Whistler wave and you heard the explosion. This time you're going to see the house just smoke up, and then you're going to see it explode and go flying. I'm going to turn the sound off and just explain as we go along. Here we go. So now watch the poles. You see it? It's just burning up. It's just smoking up. It's not going anywhere. And then all of a sudden the black, boom, there it goes. That's the exact same thing that we saw in the other thing. All right, I guess I'm going to close it up for today at this, but I'm going to I have a lot more on this, because we had done a lot of light experiments. Rod Warren basically did the actual experiments. I do the atomic theory primarily. Now, this is the Whistler wave that I just heard. And then a little while later, the black came, bam, out it goes. Now, as we saw, the house burnt up, being here, burn, 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 burn. Nothing's moving. And all of a sudden, the black came and swept it away. We are missing basically the whole reason we have global warming, and it's the scrub. It's the scrub. Yale has everything completely backwards, and they all do. And they, the refusal to engage with what I showed and the stuff, like right here, this is from Fermilab. And I've been trying to show them, I have your particles. This is going on 8 years now. I've been trying to interact with them, and they refuse to discuss it. Lawrence Livermore, CERN, all of them. And I went to the University of Geneva for particle physics, and I told them all about our research, and they were impressed as far as I could tell. They didn't fight back at all. But I don't know why nobody ever takes this into account. I said, can I work with you? They said, no, we'll follow you on Facebook. I said, well, are you going to do anything about this? Well, we'll follow you on Facebook. I said, okay. And apparently they did make some changes at CERN, because they focus, which I said, we focus, and we use CMOS. And they put in focusing magnets, and they put in hardened CMOS monitors so that they could see these particles. But still, they're using gigantic protons, which have, instead of one big mass like that, I mean, instead of what it should be 1,823 little particles, they're using these big gigantic jobbers and smashing it to bits. We started with the smallest parts. We started with just 2 of these. back to back. It's a photon. And that's the smallest particle that exists that's stable. Below that, these two, they want to snap together as a dipole. Dipole-dipole reaction. That was my theory in 1970. Dipole-dipole. There's nothing but dipoles. You can't have one big gigantic positive, one tiny little negative. They'd snap together. They wouldn't stay apart. It was just crazy. Nobody understood it. Even if you look up Yale and the quantum physics and see Dr. Shankar, who was a nice guy, but he said nobody understands quantum physics. It's just wrong. Because everything's made of these tiny little particles, which is the muon and the electron neutrino. And you take 1823 of them, and you end up with a proton. And that for some reason, they're stable in these specific numbers. And these, they know, I can understand, they are stable in these specific numbers. And I really don't know why. There has to be something to do with a frequency that, I really don't know why. I got to be honest with you. I can't come up with an answer for why these things would become stable as their different frequencies get bigger and bigger and bigger and just not fall apart. There's some reason that they're there in these big pieces. And they say they all came from the Big Bang. And I don't believe that. I think they're from enzymes and bacteria breaking down using isotopes. Because in between every one of these, like I say, hydrogen is 1,823. Helium is like 7,350 particles. And by the time up you get there, hundreds of thousands. And enzymes can come in here and go and break them down and change them into different things. And that's why I think some of the old alchemists, they had enzymes. They knew how to use enzymes to cleave off things, to drop something down into the gold or who knows what, mercury into gold, that type of thing. There is ways to do things. And I think they've missed them all because they don't understand how many particles exist between mercury and gold. It's just thousands, hundreds of thousands probably. And that's the key. They don't understand the nature of the particles. They don't understand the nature of the universe. They don't understand the nature of anything. And they don't want to understand it. They want to go for funding, and more. The more confusing they make it, the more money they make. This is what's happened. And once they realize that there's no more hiding from it, they steal it from whoever puts it out. And that happened to me with my Mudfossils. Same people, Yale. I published my paper a year before theirs, and I gave them all my research back then, and they published a paper virtually identical to mine. Had all the same points in it, and they called it exceptional. Well, hold on. Okay, this is when I wrote the paper about fascia-facilitated fossilization a year before Yale published their paper. But I had already given all this stuff to Derek Briggs, along with CAT scans and DNA tests and all that stuff. And before that, nobody was looking at this at all. Nobody was looking at. And even he told me I had to be crazy, I had nothing but rocks. Well, no. And then they took credit for it. I don't think that's right. So mud fossils are exact copies of original creatures separated on the fascia and skin planes. Exact copies, that's true. And it had a lot to do with the silicon, 50 times the silicon. Now, that's basically what they wrote in their paper that we paid for from NASA and so forth. All right, high silica saturation states. That was the biomineralizer. It infused into them, preserved them. And they said basically the same thing I said, only they don't realize that it was all creatures had bones and teeth and everything else, but they did something called nucleophilic substitution. They should look that up at Yale, which means they got invaded. And there was a replacement of the original materials by invading molecules in this hot water flood. And that's another thing they don't understand. We almost got hit by Venus, which almost boiled a lot of the waters in the oceans and so forth, created this worldwide flood. And all of this silica, extreme silica. Here they say right here, look at this. Preservation through the rapid precipitation of silica cements. Well, what's the precipitation? First of all, it was when Venus almost hit Earth. It combusted all the atmosphere and condensed everything, and it rained boiling water, and all of the oceans on Earth became tumultuous, and the deep layer of silicon, which is about a couple of miles thick, way down in the ocean, was stirred up, and it came up, and they said this has never happened before, this one particular silicon event. And I can understand that because we were almost hit, and all of the ocean waters that are, the clear water that we drink and eat out of and stuff like that and swim in, way down inside, this heavy stuff is the silica-rich fluids. And that all came to the surface, and that's what created all the mud fossils. All right, and I told them all this stuff, basically. I didn't realize about the silicon layer, I have to admit that. I did know that there was 50 times more silicon in the specimens that I was looking at, and where that silicon came from. I was expecting it came from boiling off the skin, because the skin of creatures has 50 times more silicon than your fluidy, gooey inside layers. The skin is just a tough layer that's hard to penetrate. So anyway, as far as I'm concerned, they just took credit for my work. And they make a whole big thing out of it. And I had written papers about this. I had written a book already, and all my CAT scans and DNA reports and all that were done. So I do have a little bone to pick with Yale. I think that was not correct what they did. They didn't mention me whatsoever. And actually, I had a very hard time with them. I was very upset. Let's put it that way. And they knew it. And they still know it, I'm sure. All right, I'm going to leave it at this. This is the book I wrote. And it's called Mudfossils, Velikovsky, and Minds in Collision. That's when Yale just turned away and said they wouldn't. And this was in February 2016. They published their paper the end of 2016, October, I think it was. And it's only 99 cents on Amazon. You just get a text, or I don't know what you get. You don't get a book or anything. But I just wanted it to be known. And I said the discovery of mud fossils a few years ago led on a journey that can only be described as wild and crazy. The evidence uncovered is discussed in many links to videos that prove the claims that are made. I was so destroyed with this book by academia, and they tried to link me to every kind of crazy that was out there. And they, I was a nutcase. I was a conspiracy guy. I believed the Earth was flat and there's no space and all. It was all not true. And the only reason was because I found giant creatures that were humans, and I had them DNA tested and everything else. And the first thing out of Yale's mouth was, "What are you, a creationist?" And at that point, they were firing people for finding these things. Look into Mary Schweitzer, Mark Armitage, and people like that. And then everybody shut their mouth so they wouldn't be fired, because they took enough heat. It's just like Velikovsky. That's why I put his name in here too. He was destroyed by academia for coming up with true research about our ancient past. And part of it was this thing about Venus almost hitting Earth and creating all the mud fossils. And that's why he was my inspiration for going deeper and deeper and deeper into this. All right, so anyway, I love you all. Merry Christmas. Have a Happy New Year if I don't see you. And stay safe, and pray for peace. See, they're calling it exceptional preservation of soft-bodied creatures promoted by silica-rich oceans. Exactly what I said to them. Edicarta biota just means a layer, and it's one worldwide layer because of the Great Flood. They basically took my research, plagiarized it. I gave it to Derek Briggs. For years I was trying to communicate with him, show him. So there's no, and then you get to the end of this, and here's what the whole thing was all about right down here. Funding. All right, and NASA paid them to do this, which was my research. Support for this research provided by National Science Foundation, Earth Sciences, a grant from the American Fellowship Society, Clark Fund, NASA, Tarhan and Briggs at NASA Astrobiology Institute. These are all funding. And this was my work. It was exactly what I told them, almost word for word. And they claimed that, and this was 2016, and I had all that done and presented to them at the same time. And they say it was earliest fossilized ecosystems before anything, even teeth or bones or anything, which is all wrong. They got everything wrong, but they said, yes, there was these exceptionally preserved soft-bodied creatures because of the silica-rich oceans. Exactly what I said to them. Identical, word for word almost. So this is what we're up against, and that's why there is no advancement in science, is because it's all about self-preservation and funding now. So that's just another day in the never, never land, because it's never, ever, ever going to happen that we get anywhere. With places like this too. I said 8 years I was trying to present this to Fermilab. There is no appetite for anything that upsets somebody else's life, and I mean it's going to be upsetting. I'm sorry. That's just the nature of science and research and exploration and discovery. It's not a static process where everything stays the same when you're done. No, something's going to happen. This is going to change. And once we should be able to get free energy right now. I've been showing this over and over and over and over for 8 years. Send that laser through there and harvest just the white. I showed you the white has no mass. And this is the same white that you put in your car. You drive your car for 500 miles. It weighs the same, charged or uncharged. It doesn't matter. This has no weight. It has all that burnt up the house. The house just never moved. Why? Because there's no weight to it. It's just infused with energy. And that's what this does. We could pump this down, because we can squirt that. We don't have a big bomb go off once every 15 days or something. We can squirt this all day long. You just turn it on and it never stops. And back here you have your harvester. And that's all we want is the white. That's all you want to put in your car or make your electricity run or anything. And look at the energy. It's high luminosity. They're trying to do it by 2029 or something like that. CERN is going to have high luminosity. We got it already. That's as luminous as you can possibly get. You see these fields here? These are nothing more than these, which is nothing more than a particle of light coming through the air, but you couldn't see them because this one's you can see because it's being accelerated going forward. You see how fast that's getting accelerated? These are being pushed at going backwards. That's reverse EMF, electromagnetic force. That's the only reason you see them. They're everywhere. They're all over the place, but you don't see them until they're getting pushed back at. And this is fission and that's fusion. This is raw energy. Raw energy. So we got a whole new way of thinking to come up here. But in order to do that, you have to get somebody to listen. No listening is going on. There is no listening. All right, I love you all. Merry Christmas. And hopefully we can get something on this done. It'd be nice to get some free energy, first of all. And who knows what we could do about the planet, but it doesn't look good. It's just been too much stuff taken out of the Earth. The Earth is collapsing. So on that note, well, we just hope for the best. But we got to get somebody to pay attention. No paying attention. They don't even understand what gravity is. They don't understand what light is. They don't understand how the nucleus is constructed. They don't understand about the layers of the atmosphere, the ignorosphere. They don't understand literally anything about this stuff. And they're making all these assumptions, and that light just goes forever and never slows down. Well, that's impossible. Light has to come through these fields. Obviously, it slows down. That's what the redshift is. It's not that the universe is expanding so fast that light's getting sucked away so fast it's turning red. No, it's just coming slower, 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 slower. All right, so there's so much wrong that I got a lot of videos to do. A lot. All right, so thank you, my friends. I love you all, and let's just see if we can do something. If we can get some free energy, that would be a start. Okay, it ain't bragging if it's true, and it's true. I've been doing this stuff my whole life. I fully understand what I'm talking about, way more than what these other people are talking about. And I have had this theory since forever, that all there was is dipoles. There's no such thing as these just gigantic protons. I've done all of the chemistry, I've done all of the magnetic properties, and all of the polarities, and it breaks down to electron flood theory. Everything's made of dipoles. Dipole electron flood theory. A nucleus and a proton is not simply big particles like this. They're all little tiny particles. And the transfer of energy, this was written in 1970, the transfer of energy is from light to atomic vapor, and that's what we're talking about right now. And the atomic vapor is what's causing our overheating, our global warming.